Okay, so I'm gonna read about Wikipedia about Kepler-1649 because I need more information about the planet. Also, this is my 100th video posted. Yeah, it went. Yeah, 2 years ago today, I posted my first video called my first video welcome, and this is it. Okay, Kepler-1649c. So, Kepler-1649c is an Earth-sized exoplanet likely rocky orbiting within the habitable zone of the red dwarf star Kepler-1649, the outermost planet of the planetary system. Discovered by the Kepler Space Telescope, it is located about 301 light-years or 692 parsecs away from Earth, in the constellation of Cygnus. Okay, this is Earth, and this is Kepler-1649c. Kepler-1649c orbits its star at a distance of 0.0648649 AU, or 9.71 million kilometers, or 6.3 million miles from its host star. With an orbital period of roughly 19 days, it has a mass of 1.2 times that of Earth. Also, 1.2 times mass of Earth is relatively fine, but the gravity will be a little bit stronger, and has a radius of around 1.02 times the Earth, and it's an Earth-sized exoplanet. Based on its mass and radius, it is likely a terrestrial planet, though its proximity to its star means it may be likely tidally locked. Also, did you know that the TRAPPIST-1 planets are all tidally locked to their star? Yeah, that's because their proximity to a star. So, the outermost planet of TRAPPIST-1 is TRAPPIST-1F. And I heard that it orbits 6 times more closer than Mercury does to the Sun, or maybe about 7 million miles. Kepler-1649c is estimated to receive about 3/4 of the radiation from its host star, that's the Earth. And you can see some spots of water right here. Estimated under the sun. In 2017, Jeff Kulin, the director of SETI's K2 Science Office, described it is the it has the most similar planet to Earth found so far by the Kepler-6 Space Telescope. The planet was initially deemed a false positive by Kepler's Robovetter algorithm. The Kepler False Positive Working Group, or KFPWG, published its recovery on April 15, 2020. It is the first scientific description was published in the Astrophysical Journal Letters, with first author Andrew Vanderberg in April 2020. Hold on. Also, did you guys know that I was 8 years old in 2020? Yeah. Yeah, I sounded very young with a high voice. Also, let's continue. The physical characteristics: mass, radius, and temperature. The exoplanet was identified as a rocky planet by NASA. Also, NASA means NASA's full name is the National Aerodynamic Space Administration. Kepler-1649 is a type M red dwarf star, estimated to be roughly 1/4 the radius of the sun. Also, 1/4 equals a quarter, or 25, or 0.25, which means that a quarter equals 25 cents. Okay. With only 2 confirmed planets in its orbit, the other being Kepler-1649, other being Kepler-1649b. Kepler-1649b is similar to Venus in our own solar system in 2 days. Both Kepler-1649 and Venus have orbits roughly half the radius of its next known planet, Kepler-1649c and Earth, respectively. And they are similar in size. Kepler-1649c takes only 19.5 Earth days to orbit its host star Kepler-1649, an M-type red dwarf. It orbits within the habitable zone of its star, Kepler-1649. Okay, so habitability. Here was an Earth photograph of Kepler-1649. See surface, and you can see spots of water right here, and you can see Kepler-1649b in the distance. Oh, main article: habitability of red dwarf systems. Wow. While the exoplanet still does orbit within the star's habitable zone, due to lack of information on the exoplanet atmosphere, it is unclear if Kepler-1649c can sustain liquid water on its surface as of 2021. But it's not 2021 right now. It's 2025. But 2021 was 4 years ago. No solar flare-ups have yet been observed from the host star. Nothing the less. Scientists believe that such stars are prone to frequent solar flare activity, and that such flares may have stripped the exoplanet's atmosphere and hindered the prospect of life. Climate. Very little is known of Kepler-1649c's comet. It receives 75% of the light from its host star that Earth receives from the sun. Therefore, depending on the atmosphere, its surface temperature may be similar enough to the temperature of Earth that liquid water may be present. It is unclear what the composition of Kepler-1649c's atmosphere is. Orbital evolution. Orbital evolution models show that significant oscillations of eccentricity under the gravitational influence of Kepler-1649c's are likely, but climate would remain Earth-like for most initial parameters. Okay, so we got Kepler-62f, Kepler-186f, Kepler-442b. Also, Kepler-442b is an Earth-sized exoplanet. It's a big Earth-sized, a big exoplanet, just a few times larger than Earth, but it has a red landscape. And LHS 1140b, list of potential habitable exoplanets. Kepler's Proxima b, TRAPPIST-1e, habitability of red dwarf systems, and Earth analogs. Let's do LHS. So LHS 1140b is an exoplanet orbiting within the conservative habitable zone of the red dwarf star. The red dwarf star LHS 140b. It is about 5.6 times the mass of Earth and about 70% larger in radius, putting it within the super Earth category of planets. It was initially thought to be a dense, rocky planet, but we find measurements of its mass and radius and found a lower density than previously estimated, indicating that it is likely an ocean world. Well, it kind of sounds like ocean world, like GJ1214b, and a massive ocean world, and with 9 and 9 to 19% of its mass composed of water. LHS 140b orbits entirely within the star's habitable zone, and it gets 43% of the incident flux of Earth. The planet is 49 light years away and transits its star, making it an excellent candidate for atmospheric studies with ground-based or space telescopes. Host star, main article, LHS 1140. LHS 1140b orbits a red dwarf star, LHS 1140. It is 18.4% of the mass and 21.6% the sun, with the spectral type of M4.5V. The temperature of LHS 1140 is 3,096 Kelvin, 2,823 degrees Celsius, or 5,130 degrees Fahrenheit, which is quite hard for a red dwarf star. And its luminosity of 0.0038 times that of Earth, and at least 5 billion years old. For comparison, the Sun is 1 solar mass and radius. It has a temperature of 5,778 Kelvin with 1 solar luminosity and is 4.5 billion years old. Actually, it's 4.570 billion years old, and has a spectral type of G2V type star. Okay, guys. So we're gonna continue in the next video about LHS 1140. I hope you all enjoyed the video, and I'll see you guys in the next video. Bye, guys.